Qidi's latest lineup of printers is looking to take aim at the widely popular Core XY printers that are flooding the market. Today's video is going to feature the X-Max3, and the question is, can this printer stand up to the competition? I have clocked over 700 hours of printing time with this machine, and I can tell you it absolutely can. Now that doesn't mean it's not without its faults, and in today's video, we're going to go over those as well as its features. And here we go. Folks, welcome to the channel. I am Leo of Prince Leo 3D. Thank you so much for joining me on another slice print review. And in today's video, we're going to be taking a look at the Qidi X-Max3. This is a fully enclosed Core XY pre-assembled 3D printer looking to compete along the same rail lines as the Bambu Lab series of printers, as well as the Creality K1 and the K1 Max. What makes this 3D printer stand apart from the rest of the field? Well, it has two major features. One is the build volume. This has the largest build volume amongst other pre-assembled Core XY 3D printers. The build volume is 325 in the X, 325 in the Y, and 315 millimeters in the Z axis or the vertical height. That is the largest amongst competitors. The closest comparison is the Creality K1 Max, clocking in at 300 millimeters cubed, meaning 300 millimeters in every direction. Now, build volume is great if you're looking to print single objects at very large scales, but what about the internals? Well, that is the second feature that puts this printer, in my opinion, head and shoulders above the rest, and that is the firmware installed, and it's Klipper. Klipper firmware was developed by Kevin O'Connor, and it allows us more speed, more precision, and most importantly, more control over our 3D printer. No longer do we have to compile and flash firmware in order to make updates and edits to this 3D printer. It's all going to be done through an editable text document. This allows us to add features, to modify features, or to change settings as we see appropriate over the timeline that we own this 3D printer. We have full control over it. Something else that Klipper offers us that we have to start thinking about now in 2023 is security. We can wirelessly send prints to this 3D printer through our local network. That means if I'm on my laptop or if I'm on my PC, I can slice a print, create that G-code file, and then wirelessly send it to this 3D printer to begin printing. There's no third-party access. I'm not sending that file from my laptop to some cloud service and then to be shot back down to my printer. It goes directly from my laptop, from my PC, to this printer. Normally I have 3D printers or whatever I'm showcasing directly on the table right next to me, but this is huge. Qidi says that this is an 84-pound machine, and I'm going to take their word for it. I had to move it down the stairs, and here I don't want to start lifting it anymore to try and weigh it, but it is massive and it is heavy. It has a very large footprint. Now, is that a good thing? Is that a bad thing? Ultimately, that's up to you. The footprint on this 3D printer is not only what you see here, but also behind it, because that is where the filament is mounted in a dry box at the back of the machine, which means that whenever you want to replace filament, you need to access the back of the machine. If you have room behind the machine, that's the best way to go about it. If you have to pick up and tilt this machine every time, it might be a little rough. Like I said, this is nearly 84 pounds. Trying to manipulate it is not always the easiest. What I did was I have this Alex drawer from IKEA. It has wheels on the bottom. I was lucky enough to have this already. I placed the 3D printer onto that, and now I have some pretty good movement of it. That is what I decided to do with this machine, and it made my whole experience that much better. So really consider that if you're going to buy this, and find a very suitable location for it. And if you can, something like I have, this IKEA drawer on wheels that I can roll around my location and get easy access to it without having to lift up this complete giant of a 3D printer. What else does the X-Max3 offer? Well, let's open up the door and we'll dive inside. Inside, we'll find this enclosure is actively heated, meaning there is a heater in the back corner which allows us to adjust and control the temperature within this enclosure, and that is a standalone feature that none of its competitors offer. In the back is a carbon filter, and to the right side is an auxiliary cooling fan. Another important feature is the reinforced metal bracket Qidi has added to the bottom of the bed. The previous iteration of this machine had a very weak support system at the base of the bed. Over long print times, or if the enclosure got too hot, the position of the print bed would not be accurate. That means your Z offset would be incorrect, and ultimately your prints would fail. This was a titanic design mistake, but Qidi did the right thing, did their research, and have delivered a superior product. And that is no longer an issue. Also, the print bed. This is a very thick piece of aluminum, which is awesome at holding heat. Now, this will take a little longer than normal to get heated because of the thickness, but ultimately, this is a good thing and it maintains proper heat throughout. Looking at the hot end, this is a direct extruder and it is dual geared, meaning it's going to pull and push filament on either side of it, which allows for more consistent extrusion. The hot end itself comes in two pieces. While this does look like a single unit, akin to the Bambu Labs hot ends, you can replace the nozzles on this, which is a real benefit because we can use some of those volcano-style aftermarket nozzles like the CHT, which allows for higher flow, meaning higher speeds. Moving away from the extruder is this long Bowden tube. Now, this is a direct extruder, so the gears are on the hot end, but this is what's called a reverse Bowden system, which means the filament path from the spool to the extruder is being stabilized by this tube. On the back of the machine is a filament run-out sensor, and while printing, when there's no filament detected within it, it will call a macro, which will pause your print and allow you to refill filament. And at the very back of the machine is where the filament is mounted. This comes with a filament dryer box, meaning you can place filament in here. There's an area below for a desiccant packet, which it comes equipped with, which should keep filament dry while you are printing. And for certain high-end filaments like carbon fiber nylon, this is a real necessity while printing longer prints. Now, it's not all sunshines and rainbows with this 3D printer. I really like it. It's definitely going to taint my vision. I have a little bias because it's been so good for me, but there are some downsides. The memory that comes with this 3D printer is really small. It's almost akin to a Raspberry Pi Zero. This only had 600 megabytes of available free space, which will be used up in no time. However, Qidi has set up the USB thumb drive in the back of this in such a way that every time you plug it in, a directory or a folder is created in Klipper, and we can draw G-code files from there. So we have the ability to wirelessly send print files to that thumb drive while it's plugged in, and we can print directly from there. Another aspect of this 3D printer that some people see as a downside is the fact that it does not do any auto Z offset. This does come with a bed probe. It will create a mesh for us and we can use that, but the Z offset, the distance the nozzle is from the bed, we need to calibrate that ourselves. And while that is a downside because it's not going to do it for us, it also gives us a little more agency over this 3D printer. We can control how the Z offset is, how high it is, how small it is. If we're using different materials, we can adjust that Z offset. So it is going to be a little more work for us, but a little more work means a little more control, and that's a trade-off. So is that a bad thing for you, or is that a good thing? While this doesn't come equipped with a camera, once we plug one into the back of the mainboard, it will turn on and it will start working. Qidi has given us a text file that allows that to happen. So we do have the ability to use a camera. And once we get that ability, we can now use a plethora of Klipper's features. One of those is OctoEverywhere. Now this is a new product that I've been using. It is free of charge. OctoEverywhere basically gives us access to our 3D printer securely from anywhere in the world as long as we have an internet connection. Now for these Klipper printers, usually we need to be on our local network to communicate with it, to watch what it's printing and to send print files. However, when we add those third-party tools like OctoEverywhere, we now get a secure way to log in and remotely use our 3D printer from anywhere. So now if you thought Bambu Labs had that one up on these printers because we can open our phone from anywhere and start monitoring prints, guess what? Klipper lets you do that. And this 3D printer has Klipper. And that's another thing about Klipper. I'm going to have some videos in the coming weeks. Klipper is now the way that third-party companies or other companies are going to try and compete with Bambu Labs. And it's all thanks to Klipper. Klipper is free. You can put it on your 3D printer right now. It is what all these big companies are going to be using to catch up with Bambu Labs and you have access to it right now if it's not on your 3D printer already. Thankfully, it is on this 3D printer, so we have those tools at our fingertips. It's time to get this out of the box and printing. And aside from a few pieces of styrofoam, this is really straightforward. This comes with all the accoutrement you would expect from any 3D printer, including an additional nozzle, meaning this comes with a stock copper nozzle and then a hardened steel nozzle that you can print your abrasives with. This also comes with a filament dryer box where your filament will sit while they are printing, so they stay nice and toasty. And most all the unboxing and onboarding is done through the main screen. We're going to calibrate our Z offset, it's going to create a bed mesh for us, and then we can go ahead and tune our input shaper, which should reduce any vibrations that we will see on our finished model. And after we load up some filament, it's time to slice a model and get going. Now, when I attempted to download the Qidi slicer, I had issues and they were completely on my end, not their fault. So I ended up using Orca Slicer. I've been using this slicer for quite a while. I really like it and I feel very comfortable with it. Not only that, this already had a profile for the Qidi X-Max3 preloaded on it. So I loaded that pre-registered machine, I sliced a benchy and sent it to the build plate to see how well this handled it. And now my first series of prints were all done in PLA. That is the easiest, that is the most common material. So you want to start there as a good jumping off spot. And this printed very well. My first print, the benchy, came out a lot better than I expected, aside from a little stringing here or there. I moved on to some more prints. I tried a few articulated prints with joints. And it wasn't too long until I noticed some tearing on the outer walls. This screams of a flow issue to me, so I wanted to calibrate that. Now, lucky enough for me, Orca Slicer has a built-in flow calibration. This calibration creates a model where volumetric flow rates will be tested upon. It will start at the lowest flow rate towards the bottom, and as it moves up in height, the flow rate will increase. Once you start seeing degradation in your printed part, that's when you know the flow is too high. After the testing was done, I settled on 18 cubic millimeters per second for an accurate flow rate. I probably could have stretched it a little bit, but I wanted to be conservative, so this is what I started out with. And after I brought the flow rate down to 18 cubic millimeters per second, this printer was buzzing. I mean, it was still really, really fast, and the prints were coming out marvelous. I printed small models, big models, helmets, busts, everything. This thing knocked PLA out of the park. I was also using Klipper's adaptive mesh and purging protocols, so I wasn't probing the entire bed before each print. I was creating a bed mesh specifically for the area of the print bed I wanted, which certainly helped with those first layers. When all was said and done, this did a great job on my PLA prints. I was really happy with how they all turned out, so I wanted to switch to a new material and I decided to go to ABS. ABS, known to be a little harder to print, we have to fully enclose this printer to really utilize and harness its ability to not have ABS warp while we are printing. And the X-Max3 really did a great job with it. Again, I did do a flow calibration on this before I started, and then I went right into this Darth Vader bust by Eastman, and it turned out awesome. This was a pretty long print based on how I sliced it, and there was no warpage seen on this part whatsoever. This printed just as easily for me as PLA did. After that, I jumped up to what people consider an engineering grade material, carbon fiber nylon. This is known to be a very tough material to print because it requires a high hot end temperature and a high bed temperature. We also want the printer fully enclosed for this. Nylon, also known to be extremely hygroscopic, meaning it's going to suck in any water vapor that's out there in the air, so the filament dryer box is essential while we are printing this material. Now, this is the only material I didn't do a flow test for, and that's simply because the price on this material is extremely high. And of course, because this was carbon fiber filled, I needed to switch to my hardened steel nozzle before I attempted this material. Carbon fiber looks great, it printed well, and I was really happy with the results. The next material was PETG. This is known to be a little easier to print than ABS and maybe a little harder to print than PLA. I didn't have too many issues with this whatsoever. I did lower my flow rate down for this material quite a lot, and you'll see those flow rates towards the end of this video. And that could be due to the brands that I had sitting around, Possibly it's because they were older, but there was a noticeable decrease in the flow rate, which of course means decrease in the overall speed at which I was printing. After PETG, I decided to try ASA. This is very similar to ABS. It requires a high bed temperature and high hot end temperature, and it is prone to warping, so we need to be fully enclosed while we are printing. Now, for all the materials I printed on this, ASA actually printed the fastest, and it produced the most accurate prints. Normally on these Orca cubes, I can't fully thread in the nut that you print alongside, but ASA allowed this to fall in place nearly to a mirror finish. I was really happy with how this material printed. It was a beautiful color and it was very easy to print with. I had no issues whatsoever. Yet again, the X-Max3 knocked it out of the ballpark. And the final test was for flexible filaments, namely TPU. I was worried about the long filament pathway from the spool to the extruder with this material, but it did not give me an issue. Now you'll notice I use 0 degrees Celsius as a bed temperature. I never use a heated bed when printing TPU, and I don't enclose this. While you'll notice a decent amount of stringing, and that's simply because I didn't take a lot of time to curate my TPU profile, the fact that it can print TPU as well as it does leads me to believe I should be able to clean up this profile so it's printing TPU just as crisply as it can print PLA. Now, of course, I did lower the flow even more for this material, but that's not out of the blue. This has the most elasticity among all the filaments here. I was going to slow it down anyway, so I wasn't shocked when this had to print just a little slower, or maybe significantly slower than the rest of the materials. Still, job well done. And now to flow. Every time I started a new material, the volumetric flow rate test is what I printed. Ultimately, flow rate will determine our speeds. And these next two graphics will show the flow rate and the speeds that I printed out throughout these tests. And while I didn't go crazy testing the high-end flow rates, I did do a few tests. While making this video, a company reached out to me by the name of AceAddity, highlighting a new flash PLA. This material should print like PLA, but it should allow higher flow rates. I also tried a CHT nozzle. These nozzles are designed so there's more surface area touching the filament as it is melting, thus it melts quicker, and you should get higher flow rates. And during my test of both the AceAddity Flash PLA and the CHT nozzle, I was able to increase my flow rate at a rate of 2 cubic millimeters per second, which allowed me to ultimately print PLA at 20 cubic millimeters per second with both the AceAddity filament as well as a CHT nozzle. Now, while this data may be anecdotal and it's a small sample set, it does show that there are some filaments and some nozzles that will allow for an increased flow rate. That has been my experience with the Qidi X-Max3. Again, I have over 700 hours of printing time with this, and I've enjoyed every single minute. It's been an awesome machine for me. I've had to take the nozzle apart a number of times. I had an issue with the bed, but even with all those things, I was able to get my hands dirty. I was able to fix problems, mostly self-inflicted problems, granted, but I was able to get my hands dirty, fix it, and then have a usable 3D printer. So, will this printer require a little more work than, say, a Bambu Labs X1C or P1P? Absolutely. That is not in question. The question is, do you want to do that work? What features do you desire? For a complete beginner, someone who has no idea about 3D printing, has a low amount of time to invest in it, and just wants to get models, those Bambu Lab printers are tremendous. You unbox them, and 15 minutes later, you can be printing. However, there are some non-starters for people using those printers. One of them is the fact that every model you slice gets sent to Bambu Labs and then back to your printer. That means they are monitoring every single G-code file, every single model that you execute on that printer. And some of the documentation that comes along with these printers when they're up for a review is points to hit. And one of the points was speed, that this is faster than any other printer out there. In my experience, that's not the case. They're all about the same. My Qidi X-Max3 finishes prints at about the same rate as my Bambu Labs printers. I have a P1P and an X1C. There doesn't seem to be any real determining line as to which one's faster, which is good because they're all really fast. They're way faster than even my VoxLab Aquilas that are running Klipper, or my Ender 3 Pros that are running Klipper. Those are fast machines. These Core XY printers, though, are a little faster and a little more precise, which is really the key. Ultimately, we want to print nice-looking models. If we can do that while also increasing our speed, which decreases print time, that's a great thing. And this printer is definitely capable of that. I wouldn't buy all the buzz, though, that this is the absolute fastest printer out there. In my experience, they're all fast, and they're all about the same. Thank you so much for watching. If you are considering this 3D printer, I'm going to put a link at the bottom. It's an affiliate link. It gives me a little bit of money. It doesn't cost you anything if you're thinking about it, and I appreciate that. You can also join the Prince Leo 3D Discord. There's going to be a link in the description. It's a great place to go for questions, to show off your prints, to just talk about 3D printers with like-minded people. It's always chatty. It's always a great bunch of people, and I thank everyone that's been there, and I implore you to join, because the more people that share in this experience, the better it becomes for everyone. If you have not yet subscribed to my channel, please do. I appreciate it. You can even like this video if you did like it. I don't want anyone to lie. Subscribing to this channel is a free and great way just to give back and show that what I'm doing here actually is having an effect, and I'm going to continue to be making these videos. If you want, I now have a Patreon. If I've helped you in such a way that you think monetarily you need to say thank you, I appreciate it. Never necessary, but I always appreciate it. It's very, very nice when people do that. I thank all my Patreons for their support. And now, as always, until next time, boys, girls, everybody else, keep on printing. So we have a new camera setup, new mic setup, because the new camera kind of made it happen, and the camera won't allow these lights to go on. So I apologize. I didn't know that was going to be a thing. So I'm going to try and get some better lighting behind me. So if this is ticking you off, apologies.